No. It contains molecules. So what that molecules will do? All of you, please be alert because this is the concept which will help us a lot. We have plenty of numericals in this one. So what is the state of molecules? They'll be continuously colliding. No? So these molecules will go and collide. Then this piston is having a mass m. Next question comes, who is balancing the weight of piston? There's a gas. There's a cylinder. Even the air will also exert force, P naught E. Who will balance these two forces? So let's get into mechanics. We know mechanics here. So we know like a this particular the weight of piston will act, the atmospheric pressure force will act P naught A. So because of this, the piston should move down. No? So if I go and observe, so what is the state of this piston? It is at rest. It is at rest means it's in who should balance the force. So here what I'm telling is that the pressure force. So what is the P? P is the pressure of gas. So this gas will exert a force. That is what P into A. Means now, sir, is it gas is having any, sir, anybody is there inside? Is there somebody is there inside? See, this is what you have to ask yourself, sir, who is there inside? Who will balance the weight of the piston and atmospheric pressure force? So let me put it like somebody there inside. Inside what happened? Some sort of person is there. And that person is balancing the weight of the piston and atmospheric pressure force. Will I agree? Okay, we'll go and check it. Anybody is there inside? Okay, we are verified. Nobody is there. So forget about gas. If there were no gas, then who will balance the weight of the piston and the atmospheric pressure force? I think definitely that person. Will I agree? I want students to really think. Huh? It's not that something you should remember formula. Okay, fine. KTG got over. Person balances the weight of piston and atmospheric force. Okay, I'm able to write it here. That's what no, he will lift it up. Able to imagine all of you. I'm saying he is lifting up, he is somehow managing it. No, we'll go and see. Is there really such person? No, what is present? Only gas is present. Then how come gas will have any arms? Tell me how gas is able to balance this weight of piston. See, it may not be very heavy piston. It can be 100 kg. Don't think that, okay, sir, 1 gram. No, 100 kg. I think some of you will be having air bed and you're going to lie down in that air bed. Tell me like, hey, if it's balancing your total weight, I think you are not something, not a 1 gram, 2 gram person. No, it is going to balance your weight. So therefore, how it will balance? Anybody wants to answer, please? What all you feel, you can reply it. Huh?
Intermolecular repulsion.
Intermolecular.
Repulsion.
Okay, intermolecular repulsion. I'll write it down. Next. Next, anybody?
So surface molecules.
Surface molecules. Yes, ma. Further, surface molecules. No, don't type it up. Please talk with me. Don't type it. I'm not going to see the chat. Yeah.
Sir, air molecules in the cylinder are continuously in collisions with the piston, sir.
Okay, air molecules in the cylinder continuously collide with piston. Due to that, okay, it is getting balanced. Okay, any other reason? Anybody? If I don't ask, if you are studying gaseous state, and if you don't ask, if a teacher doesn't ask, or if you don't study this, it's of no use to learn gaseous state or KTG. I'm making things clear. We are here not to gather information. Yesterday only I told you. Yes, anybody? Any other reason still? Any other reason?
Sir, there is also some friction on the piston, sir.
Okay, smooth. Okay, don't bother. Smooth piston. Smooth piston, let's not bother. No friction. Okay, yeah, see, like, yeah. What is it? Let's go to KTG. What is the state of molecule? They'll be moving randomly, you can see like this. You're seeing the spot. It'll be like this. So molecules open will be continuously, they'll collide. No, you can't say like which molecule. Better say that all possible molecules. So this molecule will go collide. Will be like this. And you can't say that it will retrace path randomly. It will be moving, colliding. So continuously open, the molecules will go and collide. Each molecule, when it collides, undergo elastic collision. Each molecule will exert a force. This molecule will go and collide. So I think one diagram is what I'll try to show at least. So this will go and collide. This will go and collide. This will go and collide. This will collide. Not one molecule, several molecules like that. It will go collide and it will exert a force. By the time this molecule after collision it moves, no other molecule will come and collide. Like that happen continuously, the molecules will be colliding. Continuously the colliding molecules will exert a force on the piston. That force is what balancing the weight and atmospheric pressure. You don't say surface molecule. Some of you are thinking that only these molecules all the time they'll be colliding. They'll be here like this. No, this molecule weapon will go collide. This molecule will be now here. Then the position of this molecule will be taken by this molecule. It will come and collide. So there are say like some 1,000 members are there. Every time, let's assume that some 20 members will come, they'll collide with piston and go. Next, another batch, next 20 will come and collide, will go. Next, another 20 will come and collide, go. Another 20 will come and collide, go. Like that, what happened? The molecules will be continuously colliding, continuously each molecule exert force. And that resultant force exerted by the molecule is nothing but I'm calling as a pressure of a gas. Able to understand? This is the core central idea. The entire thermodynamics, gaseous state, this is the heart of the discussion. Are you getting now this one? So only balance as this particular pressure. The pressure of a gas. So this will be continuously exerting. So like that, the molecules will be continuous. Only not that molecule, several molecules. So first this molecule collide. Next again, other molecule come and occupy that position. Like that, they'll collide and they'll go. Don't think that this molecule will be continuously collide. No, this collide and go. Next, another molecule come and collide and go. Like that, the molecules will be continuously exert a force. Why do they exert force? Because change in momentum. You go back to mechanics. That's why the pressure of gas is there. So why the pressure of gas? Due to collision. Finish, sure, there's no other reason. The third option is what? The correct one. There is a better idea. So why the pressure of gas? This one. So how to find out this pressure? Okay, I'll go back to the mechanics. So P naught A plus mg minus PA equal 0. Look at pressure P naught mg by A. So what we are getting? Constant pressure. The pressure of gas will be constant. It depends on what P naught plus mg. I'm able to measure now this pressure of a gas. Earlier, how I was measuring the pressure of gas either by measuring the RMS speed of molecules. able to get this one. If I know RMS speed of molecule, I'm able to measure the pressure. Now, external parameters, how this pressure of gas related to weight and atmospheric pressure force. This is what equation I'm bringing. Sir, how pressure of gas related to RMS speed of molecules? This is the formula. Are you able to? This is the macroscopic approach. We are not bothered like what is the gas, monatomic gas, diatomic gas, what is the RMS speed of molecule? Nothing. What is the pressure of gas? P naught plus mg by A. This is like a mechanical approach. This is what the gaseous state approach. Why pressure of gas? SS RMS speed. Why the pressure of gas is there? Because of the molecules, they are moving, they'll go and collide. The moving molecules, when they collide, there'll be change in momentum. Due to change in momentum, the molecule exert a force. Like that, the net force exerted with molecules on the piston is what? The pressure of a gas. Getting the idea? So the two approaches are very important. In physics, the numericals are based on this one. P equal to P naught plus mg by. And now I'll increase the I'll place some mass on it. See, this is what actually we have stopped thinking. What we have? Can you hear me?
Yes, sir.
Yes, sir.
Okay, some power gone. Okay, somehow I retain connection. Okay, let's come. I'll place some additional mass. So then what will the pressure will be? P dash. Please do notice. So I'll do one thing. Some M dash. P dash or M naught will write, no problem. Okay, now what is the equation you're going to write? P dash A minus P naught A minus mg minus m naught g equal to 0. The weight of this block will also act. What do you expect? Pressure will increase, no? So anybody, can you interpret what will happen to molecules?
Sir,
Anybody wants to tell what will happen to molecules?
sir, due to the additional mass, there will be a slight compression, no, sir.
Let it be, no problem.
So volume will decrease and pressure will increase, sir.
Let it be here. Okay, that's
That is,
okay. I'm not bothered volume. Let volume decrease. Okay, you are writing V. Okay, like V1, V2. Volume will decrease. So V dash. Okay. V dash will be less than V. Okay, fine. No.
so
Anything
pressure
further?
increases, which compensates it, which compensates the mass of the new block.
Okay, there's a story here, but what happened to molecules? Come out of your chemistry thinking. I don't want your chemistry here.
More
What happened
collisions.
to more collisions will occur? Sir, who will tell the molecules they should collide more? That's what the nature's phenomena. So rate of collisions per unit area will increase. Because like, yeah, this much of additional mass should be balanced, no? this much of additional weight should be balanced. So number of collisions will increase. So more molecules will now come and collide per second. The more force, the additional force from it will come, the more molecules should come and collide. For more molecules to come and collide, what should happen there? As what you said now, as the volume of gas will change, temperature of gas will increase. Okay, due to that RMS speed will increase. What will be that? There's the idea. So definitely if you compare the first diagram, so what shall I say? More number of collisions per unit time increases in second case. Okay, I agree this. So this is what we have to think in this way. So what is that pressure of gas due to collision of molecules? That's all. Okay. Now pressure force can balance weight mg as pressure force can balance tension, pressure force can balance spring force, pressure force can balance